we are going in page 4 of 11. Exercise number 8. Okay. It says a train A 8 no 7. Sorry. 7. Okay. A cyclist A starts off from an origin with a rectilinear trajectory at a speed of 72 kilometers per hour. Okay. We have the cyclist A, okay, which starts from origin, and the speed is 72 kilometers per hour. And at the same time, another cyclist B places 50 kilometers in front of A, okay? So here, position is going to be 50 kilometers, okay? And here is 0 kilometers. Position and position, okay? And it's going to approach the other cyclist with a speed of 36 kilometers per hour. The other one is going to be 36 kilometers per hour. Okay? They have constant, both have constant velocity. And it asks where they find each other. So we are going to do again a equation system. And so, but this is, yes, okay. 72, okay. So now, what do we want to know? The final position, okay? Final position. Final position of this one and final position of that one. But we don't know that. So, we have to do, we know that velocity equals final position minus initial position divided into the time. We solve this and we know that final position equals velocity plus initial position divided into the time, okay? And we substitute this data here and this data. So we are going to have two equations and two incognita. This one, final position, is going to be, we don't know. Velocity, 72. I'm with A, okay? A. Final position, velocity, 72. And initial position is going to be 0. And the time, we don't know the time, okay? At the end of the exercise, we are going to know the time and the final position. And for this case, B, okay? Final position, we don't know it, okay? But we can do this because we know that final position is going to be the same in both cases because they are going to find here or here, okay? So this is going to be the final position for each one. Final position for B is going to be velocity, that is 36, plus initial position. But here we are committing a mistake, okay? Be careful with this. divided into the time. Okay, and now here we have two equations with two incognita final position, time, time. Be careful because velocity is 36, but velocity is a vector magnitude because it has direction. It's a vector magnitude. It has direction, okay? Force, do you remember this? Force is not a vector magnitude because force is force, newtons. It doesn't matter if it goes in a sense or in another sense, okay? But in the case of velocity, it's a vector magnitude, so we have to put the sign. This is positive because it's going from the origin point, okay, and increasing the distance. But this is going to be negative because it's approaching the origin point, okay? So velocity is going to be negative. Take this into account, okay? It's going to be negative. And then you solve this and you get it. So for next day, exercise 7 and exercise 8. Exercise 8 is a bit more difficult because you have the time, okay? It's more or less like this one, but it's like this doesn't start at the same time. It starts later. So time is going to be, in one case, it's going to be time, okay? The original time. And in the other case, it's going to be time plus 10 minutes, for example, or something like that. I think it says minutes, okay, in time, and the velocity is in kilometers per hour. So take into account that you have to use same units, okay? Here we have kilometers hour, kilometers, and kilometers. And time here is going to be hours. But in the other case, it talks about minutes and kilometers per hour. Then be careful because you cannot use kilometers per hour and time in minutes because it's going to be wrong. You have to use kilometers per minute or change minutes into hours, okay? So for next day, exercise 7 and 8.